another fabulous session that we're going to get started in just a moment too, looking at the role of technology and innovation in enabling the energy sector transformation. I do know everybody is very interested in our last panel, of course, and everybody wants to have a little private word, which of course you should do, but you're going to be equally as interested, I can promise you, when we look at the key players that we will have from SABIC, from Saudi Aramco, and from the King Abdullah Petroleum Studies and Research Centre. So please, if I may ask you all to take your seats once again, and we will get started, the role of technology and innovation in enabling the energy sector transformation. Please, please join us, and Tariq Al Saeed, once again, from McKinsey, will moderate this panel. Thank you all.
Ladies and gentlemen, technology and innovation are playing an important role and need to play an important role in enabling the energy sector transformation. This panel with some of the key technology leaders in the energy sector in the kingdom will tell us more about these technologies and what is being developed currently in the kingdom towards more sustainability in the energy sector. We have with us Mr. Ahmed Al-Khwaitir, Chief Technology Officer of Saudi Aramco, Mr. Fahd Al-Shirhi, Technology and Innovation Leader in SABIC, and Mr. Samuel Al-Ashgar, President of King Abdullah Petroleum Studies and Research Center. Please join me in welcoming them. So maybe we can start with you. What are some of the sustainability initiatives that Saudi Aramco is undertaking, and how will these enable Vision 2030 in the kingdom?
Well, thank you, first of all. It's a great honor to be here, especially at WFES. I was one of the first, I attended one of the first conferences back in 2006 and 2007, and it's been a great conference ever since. Really great to be here. First of all, on sustainability, Saudi Aramco, of course, sees this as a very strategic area for our research and technology. And a part, as you heard from the first panel, a big part of the Vision 2030 is efficiency and how to take the power sector to a more efficient and more profitable sector. And that efficiency is enabled mainly through technology and also through fuel. And one of our areas of research, of course, in the upstream, we do a lot of research in the upstream and the downstream, is how to avail more higher efficient fuels such as gas in the upstream, and how to utilize that gas at the highest efficiency in the generation. So we do research, for example, in unconventional gas production, which has increased our reserves in the unconventional area. And we do membrane research, cutting-edge membrane research, which allows us to do separations and therefore reduce the cost of gas that would be otherwise not utilized and make it economic. So we have one of our first big projects, which was actually offered to the private sector, was Fadhili, which is a low BTU gas. We're able to utilize that low BTU gas, which in the past we would not have used for power generation. So through technology, we're able to take very sour gas now and turn that into sales gas or generation at a reasonable cost. So we do a lot of research around how to process gas and avail that gas. And because of that, when a few years back we were talking about limited gas resources and having to increase our consumption of liquids in the power sector, that's turned over its head. We've been able, through technology, to change that whole picture. And today we're targeting to have 70% of the fuel mix going into the power sector to be gas, which is the highest in the world, and of course at the lowest cost in the world. So we are really moving sustainability. From a sustainability front, of course, that means much lower emissions. You reduce your emissions dramatically with gas, and gas is really the quickest, most economic way of reducing CO2 emissions globally, and that's proven in North America. So we're doing a lot of work in the conventional resources. But not only that, we've also been doing a lot of work on the new and renewable resources. We've done research in many areas to support the adoption of renewables and just basic studies about resource quantification. So we've done studies on the wind resources, quantification around the kingdom, solar resources. We've identified the economics that can justify really large penetration of renewables within the existing grid. Initially, there was fears that the impact of renewables might have a detrimental impact to the grid stability, but actually through a lot of simulation and a lot of quantification, we've identified that in fact we can handle much larger levels of renewables, and that's part of the 10 gigawatts that you hear, I think is a great target, and I hope we will even go higher. So we've done a lot of work in that area. With the technology itself, the kingdom doesn't manufacture solar panels, for example, but we do look at the challenges faced applying those technologies. So we do a lot of work on dust mitigation. You can see our robotic dust mitigation, our robot that cleans the panels on the solar panels at our pavilion, if you have a chance. We also do a lot of work on technologies that allow us to assess damage to, for example, composite materials that are all utilized in wind, for example. So we're doing a lot of interesting research around maintenance and operation of renewable resources. So there's a lot of sustainability work going on also in the transport sector, which is an area what people don't really know about Saudi Aramco. We spend a tremendous amount of our resources in our downstream research, almost a third, on sustaining the global transport sector, on making it more sustainable. We have 3 research centers that are focused on that area. We do research, of course, in KAUST, a tremendous amount of basic research at King Abdullah University of Science and Technology around combustion and making combustion in internal combustion engines cleaner. We are doing research in Paris, where we have a research center in collaboration with IFP. And we have our own dedicated research center in Detroit, which looks at vehicle and fleets and collaborating with the automakers on integrating the new technologies we're developing jointly with them that bring together the most efficient fuels with the most efficient engines. And that's, in our view, it's basically taking diesel engines, which are the most efficient internal combustion engines, and combining them with the right fuels, which is actually gasoline-like fuels. So we've been able to demonstrate to automakers around the world that we can actually double the gasoline fleet's efficiency just by utilizing compression ignition and combining that with the right fuels. And this is an area of real promise for the industry. And like I said, in the power generation industry, the way to actually really actioning and reducing emissions immediately is by utilizing fossil fuels, in fact. Because by utilizing fossil fuels at the highest efficiency, like gas, we're able to immediately reduce CO2 emissions. Similarly in the transport sector, electrification is going to take time. To really have an impact, we need to revolutionize the existing internal combustion engine. And that's what we're working on, how to double the efficiency of the internal combustion engine for the majority of the car fleet. And it's an area we spend a lot of resources on, and we have a lot of collaborations on.
Thank you very much, Ahmed. It would be great to hear also the perspective of a leading chemicals company like SABIC on how technology can enable sustainability in the kingdom.
Okay, thank you. Assalamu alaikum. Good afternoon. I'm honored to be with you today to share with you our effort in SABIC. Sustainability for us is one of the key enablers for our 2025 strategy. It's a journey we started in 2009. Today, we see we are a regional leader when it comes to the sustainability. Our ambition and our vision to be a global leader. We started in 2009 for the mindset of must-have compliance mindset. And now we are moving toward inspiring culture as well as creating value, because we see a value that can be created from the sustainability. We set for ourselves a challenging target, aspiration target, to reduce energy in our operation, as well as reducing the intensity when it comes to the greenhouse gases, water, loss of the material, So we set a very challenging target. By 2025, we need to reduce by 25%. So to achieve this, we have to look at the entire value chain, which is within SABIC operation as well as even outside SABIC, starting from the feedstock all the way to the end life of our products. So to achieve this, we need to back it up with a technology and research program. In our portfolio today, we have more than 600 project or research programs, some of which it is dedicated for the sustainability to achieve these challenging targets. In addition, we evaluate our projects when it comes to the research, the impact on the sustainability. So this is, in general, how we are seeing the sustainability in SABIC.
Thank you very much. Samer, moving to you, maybe you could introduce CAPSARC to us and the audience, before we talk about the sustainability activities at CAPSARC.
So, assalamu alaikum, good afternoon, everybody. As opposed to my friends on the right, who are the R&D, cutting-edge science and technology, we're actually on the opposite side of the spectrum. CAPSARC is an international energy economics research center located in Riyadh. And if you look at our name, it says King Abdullah Petroleum Studies and Research Center. We're not about petroleum. We're about energy, all forms of energy. We're international. We work in China. We work in India. But the majority of the work that we do now is located in the kingdom. Given the locus and the amount of activity and the amount of change that's happening in the kingdom, I would say our portfolio is more than full there. We're international. We come from about 23 nationalities. Half of us are from the kingdom. We're independent. We don't belong to a government institution within the kingdom. We report to a board of trustees, and we're also funded externally. But if you ask us what we do, we look to improve the welfare of societies, and we do that through the lens of the energy or the economics of energy. So we look at the economics of energy, we marry that with policy, we look at the economics of energy, we marry that with the environment, of course, but of course we look at the economics of energy and we look at technology. So we try to engender economic frameworks that improve the economics or improve the affordability of energy to society, to engender economic frameworks, to maybe finance affordability of technologies within a society, be it in the kingdom or be it outside, because different geographies, different countries have different contexts, and you have to engender it for whichever context that you look at it. So what may be applicable here may not be applicable to, for example, places in China or India, for example. That's a quick intro on CAPSARC.
Thank you, Sam. If we dive into sustainability in particular, how is CAPSARC looking at it?
So, again, I'm gonna bridge off from where my friend started here. I think there is so much of existing technology that can be utilized and capitalized on within the kingdom, and I don't mean this in any way before even getting into R&D. I think R&D is essential for the health of the kingdom in the long term, in the medium term, even the short term, but there is so much technology that can actually be utilized. And in fact, what we look at you look at technology from three different perspectives. You have existing technologies that could be utilized now, that through different economic frameworks and different financing mechanisms, you can actually make it affordable. And a clear example of that is in our building sector. We are one of the worst users of energy in the building sectors. 90% of our houses do not have insulation. Only recently has an institution in the kingdom, which is the Saudi Energy Efficiency Center, have started to provide regulations and reform that substantially change the way how we're consuming energy within the kingdom. They've done a wonderful job defining what regulations means when we build houses, what regulations mean in terms of what kind of, for example, air conditioning you use in the houses. A second form of energy, just a second form of technology, when you look at it, is, okay, you can capitalize on the existing technology you have, but there are some disruptive technologies that, due to regulations, that need to make its space. For example, in the kingdom, you have new technologies, you have distributed energy, for example, or distributed utilities. How do you capitalize on that within your existing power system? What are the regulations that you actually have to employ to introduce in your system such that it remains competitive with existing incumbent power producers? How do you marry that together? The third part that we look at is, again, when I look at the right with our friends, is there is that third aspect of technology that are still not developed yet. So innovation, research and development. Where are the biggest markets, and where are the biggest, or where are the gaps that actually can bring, that you can actually bridge, that can be very impactful, especially in the kingdom? So an example of that, a very simple example of that, is you can look at air conditioning in the kingdom. 70% of our consumption, our electricity consumption in power is just to cool our houses. So maybe research dollars can be spent there to improve the efficiency of our existing air conditioning systems. Another one could be going back to the insulation. If 90% of our houses don't have insulation, what type of innovation or maybe new materials can we actually employ to retrofit the existing homes that we have to significantly improve their energy efficiency? And that's maybe the third wing that I would look at in terms of at least the overall economic framework when you look at technology. Better utilizing existing technologies that we have now, the existing disruptive technologies, and how do you maybe adjust regulations to employ these technologies. And then for us, maybe, at least from our perspective, is where can R&D place? What are the markets that they can actually, that are available for penetration of new technologies? And what's the size of the gap that is there that can be bridged by developing new technologies in the existing systems that we have?
Thank you so much. Ahmed, one set of important initiatives at Saudi Aramco are the emission to value initiatives. Can you tell us a bit more about these?
So we see that there's an opportunity in a challenge. 40 years ago, when Saudi Aramco was actually was a JV between the international oil companies, 100% of our associated gas was flared, and that was because there was no value to the gas, at least in the economy of the time. But due to the foresight of, I think, the government at the time and some of the leadership, the investment was made at the time to turn that wasted associated gas, which was flared and actually very damaging to the environment, and convert that into value for the economy by taking that and converting it into petrochemicals. A major project. It was the largest capital expenditure at the time for any engineering project in history. That was the Master Gas Program, which served as the backbone of our growth for many, many years as a company. And it now represents almost 15% of the kingdom's economy through a contribution to the GDP from petrochemicals. So something that was seen by the economy of the day as worthless product, or actually a nuisance, zero value or a negative value, was turned into something extremely positive. Now we're just, where can we get more gas? That's the question we get from industry. So we believe very much that challenges can be turned into opportunities. You have to do the research, the science, the technology. You have to apply it, and you have to take the risk. And so some of that is what we do with our venture capital, for example. In our venture capital, we have targeted to identify technologies that are kind of risky. We invest in them, and we turn them into value. We create, and one of the areas we looked at is CO2. So we've invested in a company called Novomer, which takes CO2 and converts it into valuable polymers, basically into polyols, polyurethanes, the kind of things you put in your furniture and in cars and such. And we've piloted the technology and demonstrated its success, and therefore we are now scaling it up. We have acquired the technology, and that represents now one of our business lines in the chemicals business is Converge Chemicals. The Converge Chemicals line basically takes 50% of the product is made from CO2. So people don't see that. We don't see CO2 as a pollutant. We actually see it as a feedstock, future feedstock for the world. It always has been the feedstock, actually. Plants and animals have taken CO2, well, plants actually have taken the CO2 from the atmosphere and created all the life that we see in this world. So CO2 is the basis of humanity and life itself. And so our challenge is, how do we close that carbon cycle like nature has done over the millennia? Can we do that and accelerate it? We've been able to convert hydrocarbons into energy and into products at a very accelerated rate, beyond what the Earth has been able to handle. Can we now reverse that cycle at that same accelerated rate? Can we take hydrocarbons and convert them? And the amazing thing is that scientists are realizing it can be done. It takes some good science. It takes some, I would say, some risk-taking, but we can do that, and we're seeing that with some of our projects. Now, there's more than just polymers. You can do a lot with CO2. We are working on many research areas. We work in the Korean Advanced Institute of Science and Technology with our partners there on developing new uses for CO2. We're looking at, for example, piloting a new technology which uses CO2 to increase the strength of concrete cement in the manufacturing process, and takes up to about 20% more, takes up 20% of the weight of CO2 into the concrete. So there's some really interesting technologies that we like to see soon come to the market. We are continuing to look at opportunities for CO2 conversion into chemicals. We see a lot of opportunities even ultimately into fuels. So coupled with renewable energy, as renewable energy costs go down, it is feasible and it is possible, and we think very possible, to actually put the energy back into the fuel and close the carbon cycle. If we can scale that up, if we can industrialize that, that would be the ultimate sink for CO2 and actually turn a much more sustainable world, given that right now, most of the approaches that we are doing right now are not sinks. They are mitigation, they are avoidance. We really need to start looking at how do we create sinks. And so I think those technologies, in addition to the conventional EOR we've done, which is really one of the greatest sinks, enhanced oil recovery, we've done a pilot last year, which takes about 800,000 tons of CO2, injects it into our oil reservoirs, and we are studying the impact on the reservoir, but also we're looking at what is the long-term sequestration potential. So we're doing a lot of interesting basic science, and we see that there's a lot of potential from this soon. We think there's opportunities to take CO2 and actually create value out of that.
Thank you. How does SABIC think about emissions and emission-to-value initiatives?
Well, the way that we are looking at it from different dimensions. First, we need to think about the reduction of the emission, and this can be done through improving your internal processes or developing a technology that can reduce the emission of wastes, as well as unwanted gases like the CO, for instance. Second, that if you cannot reduce it or there is a limitation, then capturing. So capturing is something very important, and to make it available for utilization, like what we did with the CO2. We developed the technology, we built a plant to capture more than 500,000 tons every year. We produce CO2, which can be used in a product like the methanol, urea, or even it can go to the food application. The other element is also the utilization. I mean, is it just only will stop, as Ahmed said, that also working in developing a new application or new utilization for the emission, or like, for example, the CO2, where there are breakthrough technology where you can convert the CO2 to a valuable product. So we are looking at all the dimensions, and we have very successful stories. For instance, we were able to utilize more than 3 million tons of CO2 every year in valuable products. We are also, when it comes to the flaring, it is reduced by more than 40%. One important element, which is also beyond SABIC or through the value chain, is helping our customer. We developed more than 60 sustainable solutions that can help our customer to reduce the emission, having more or energy efficient solutions. So this is another dimension which is helping our customer, which is beyond our premises.
So I'm told that our time is up, but before closing, would love to hear from you, Samer, since you have an integrated perspective on this. What do you think are some of the key policies or enablers that we need to put in place in the kingdom to support the development of some of these technologies that we talked about?
So I was going to actually answer a different question, but and I wanted to actually bridge off what our friends were saying. You can look at technology and policy from two perspectives. You can look at technologies or policies or markets in two ways. You can leave a technology to compete its way within its market, within its own market, and do not try to disrupt it, and that's probably the most efficient way. But sometimes certain technologies would penetrate too fast, and you get, let's say, a technological lock-in, and you reduce competitiveness, and that's where a regulator, and I'm looking at our governor here, would get involved to ensure that we have competitiveness in a market such that you open a open playing field for not only the first movers who develop the technology, who are the incumbents, but the new people that would come into the market, such that you ensure competition that would lower the cost, for example, of energy in this context to society. That's to keep it short.
Very good. Thank you. Thank you for that. Thank you, gentlemen, for this very insightful, although short panel. Thank you on behalf of the audience.